Alright, hello everybody. Just want to start off with what a plane is. So, for example, what we've been working on today is something like this: 2x plus 2y plus 2z equals 8. Right, and that creates a plane like this in a three-dimensional area instead of just like a line. Okay, because now you have three variables. Okay. This is the problem I'm gonna do. I'll also post a link of it. And it's from Khan Academy. I'm gonna also link this and do the same problem like right now, because the idea is that if you don't like the way I do it, then hey, maybe you like the way that this is done. Okay, so here are your problems. Question A: 2x plus 2y equals 10, 3x plus 5y equals 21. And this one is, I want you to use use elimination. So for that one is elimination, and then for question B, this is a system of 3, and I want you also to do elimination. So I'll do A, and I'll start you off with it really quick, and then I want to really take the time to do B. So for A, let's see, 2x plus 2y equals 10. y equals 10, and then 3x plus 5y is equal to 21. Alright, and you might as well just call these R1 and this one's R2. Okay. Alright, so I can't see immediate like a substitution piece, so I'm going to do elimination. For elimination though, I do see that I can choose either X or Y. Alright, but I think X would probably be easier because they have a easier least common multiple. So what's the least common multiple between 2x and 3x? Well, that's 6. So I want one of them to be 6x and one of them to be negative 6x. And the way I'm going to do that to get this to be 6x is I want to multiply this one by 3. And to make this one negative 6x, I want to multiply this one by negative 2. So just to keep track of everything, I'm going to do 3 times R1 minus or plus negative 2 R2. Okay, and essentially how that's going to look like is you have this 6x, and you have to multiply all the way through, so 6x plus 6y is equal to 30, and on the bottom you multiply by negative 2 right here, so it becomes negative 6x negative 5y and negative 42. Okay, so at this point you could eliminate, and I'll let you guys go ahead and finish that one up. And then let me open up a new document. And I'm going to do question B. And that's what I really want to spend the time on. Alright, question B says x plus y minus 3z. And let's go back to this one. I'm going to call this R1. Alright, that's my first row. R2. That's my second row. R3. That's my third row. Alright, so what I really want to do is I want to get these down to two variables. I want to take two of them and use elimination to just make it down to two variables instead of three. And I look at R1 and R2 and it's already ready to go. These y's are ready to cancel out. So I'm going to do R1 plus R2. R1 plus R2. Okay, so that's going to be using elimination. X plus y. And as I'm writing this down, recognize that sometimes they won't be this easy. You might have to do that least common multiple thing that I just did for A. is equal to negative 10, and then you have x minus y plus 2z is equal to 3. Alright, now we can eliminate. We have opposites right here, positive y and negative y already. And remember that this was R1 and this one was R2. Right, and we don't have to multiply by anything, there's already opposites. When we combine these two lines together, we end up with 2x, well, positive y and negative y, they're gone. Negative 3z plus 2z gives me negative z is equal to negative 10 plus 3, that's negative 7. Alright, now I'm going to call this R4, right? This is R4, and this R4 is going to be placed right back onto here, so I'm going to put R4 over here, R4, and what we got for that was 2x minus z equals negative 7. 2x minus z equals negative 7. And now I need to do a R5. Right, so I need a fifth row. So I'm going to clean this document. Okay, and I'm going to do the same thing. But this time I'm going to look at this and I want to say, from the first three, I want to use something else other than R1 and R2. And I also want to eliminate y. So I look at R3 and R2. And yes, it looks like they can eliminate each other. I have 3 here and R2 here. These y's will cancel out. So I'm going to add R2 plus R3. R2 plus R3. And that's going to put me at x minus y plus 2z is equal to 3. And on the bottom, 2x plus y minus z is equal to negative 6. Alright, at this point I can combine the two because I already have opposites and they're right here. This is exactly the one I wanted to get rid of. I wanted to get rid of the y's. So I now get 3x, and just to remember, this one was R2 and this one was R3. So combining it, 3x, now I have no y's and I have plus z, and that's equal to just negative 3. So this is going to be my R5. 3x plus z equals negative 3, that's my R5. 3x plus z equals negative 3. 3x plus z equals negative 3. Good. Now, at this point, I can look at my R5 and my R4. And I want to make it so that they eliminate. See how they're both just like the problem from question A. You have two variables, x and z, and now you can eliminate them too. Well, you look over here, it looks like they're already ready to go. You have negative z and positive z. So we're going to go ahead and eliminate those by combining R4 and R5. So let's do that over here. R4 plus R5. Alright, and that was 2x minus e, minus 7. 2x minus e equals negative 7. Okay. And then I have the other one, which is 3x plus z is equal to negative 3. Okay, so these are already good to go. That z got cut off there. These two are going to cancel, and that's going to give me one variable that I can solve for. So So I can combine the two lines, R4 and R5, these two. That gives me 5x. These two cancel each other out, is equal to -7 minus 3, -10. That gives me a solution of x is equal to -2. Okay, so now I'm going to write that down. X equals -2, lowercase x. Alright, now what I'm going to do with this x equals -2 is I can plug this back in to R4 or R5, and that's going to give me the solution for z. So let's plug that in. Now I have 2 times -2 minus z is equal to -7. And showing you the work, that would be -4 minus z is equal to -7. I'm going to add 4 to both sides. That's going to give me -z is equal to -3. And that gives me z is equal to +3. So here's x, here's z. Lastly, I just need one more. I have x and z, and I need to solve for the last one. So I can plug it into either R1, R2, or R3 to get my y. So let's plug it into R2. I like the look of R2. So that's x, which is -2 minus y plus 2 times z, which is 3, which is equal to 3. Right, so now we do the work, and it's going to be -2 minus y plus 6 equals 3. I can move things around. In addition, it's called a commutative property, and now I have -y plus 6 minus 2 equals 3. That gives me -y is y plus 4 equal to 3. I'm going to subtract both sides of 4, and that leaves me -y equals -1, and that leaves me with y is equal to 1. Okay, so my solution here is this. And what I want you to write down from the videos is the solution for question B, as well as the solution for question A, and the question. Okay. So let's see, my solutions are -2, 3, and 1. So x equals -2, y equals 1, and z is equal to 3. And there's a reason why I put it in that order. It's just alphabetical x, y, z, and then you can just box that up. Okay, if you really want it to be technical, some people might even write it like this, though I won't require you to write it. It's -2, 1, 3. And we can even plug that into Wolfram Alpha just to check what that looks like. -2, 1, 3. So ultimately, we're going to be, well, I guess it doesn't want to put it into a 3-dimensional plane for me, but that's okay. We'll talk about that next time. We won't need to put it in a 3-dimensional plane, but I will put this link at the end of the video. That's it. Sorry it's so long this time. These take a while, so good practice on them is really what you need, and then we will work on it more next time in class. Specifically more word problems and Common Core based. Okay, alright, that's it. Bye.